Hi, I'm Xavier.
Hi, I'm James.
Today we will be talking about the technique USUB for solving complex integrals.
Today we will use the example of the integral from 0 to 1 of 4x times the square root of 3x squared plus 1 dx.
First, you must look for the U equation.
This is usually found in the denominator or within something else, such as a square root.
Once you have found the U equation, you must take the derivative of the equation du.
The derivative should be found somewhere in the original equation, but in some cases, such as this example, it will not be found. You must do algebra to rearrange the derivative so that it may be found in the original equation.
So in this case, the U will be the 3x squared plus 1. When you take the derivative of that, it's going to be du equals 6x dx. Now, if you notice, 6x dx is no longer found into the original equation. 4x dx is, though. So to get 6x dx to equal 4x dx, you must multiply the 6 by 2/3. And what you do to one side, you must do to the other side. So it's going to be 2/3 du equals 4x dx. Once you're at this point, you can plug in each of these into your equation so you have everything in the terms of du. So in this case, it's going to be the integral of the square root of u times 2/3 du.
And in this case, since 2/3 is a constant, every constant can be moved outside of the integral symbol to be used later.
There are two methods once you get to this point to solve to get the correct answer.
The first method involves using indefinite integrals. As you can see, we took off the original 0 to 1 bounds because in indefinite integrals you do not have bounds.
So now you must take the integral of the square root of u. So you're going to get the 2/3 times 2/3 u to the 3/2 plus c. Now the reason we have the c is because the integral is indefinite.
And then once we get to this point, it'd be easier to simplify the equation. So we simplify to 4/9 times u to the 3/2 plus c. And at this point, we can bring back our bounds from the original equation, which would be integrated from 0 to 1.
So you must evaluate from 0 to 1 using the fundamental theorem of calculus, which is the antiderivative of b minus the antiderivative of a. So this is going to be your FB, and this is going to be your f of a. Now, for the original equation, you always have the x's. For the f of b, since we are integrating from 0 to 1, this x is going to turn into a 1. And then this x over here is going to turn into a 0, since this is the f of a. Now, automatically, this would all cancel out. But if you look at the beginning here, you do have a minus the f of a, which will turn this plus c into a minus c, which will cancel out the c's. So you do not need to solve for any c's. So then overall, when you start to simplify, the f of b is going to come out to 4/9 times, when you take 3 times 1 squared plus 1, all of that to the 3/2 is going to be 8 minus the 4/9 originally. Now 3 times 0 to the second is just going to be 0 plus 1 to the 3/2, which is just going to get you to the 1. When you simplify from there, you're going to get 32/9 minus 4/9. So 4/9 from 32/9, which will get you the answer of 28/9.
And now we will show you the method 2 for u subintegrals. First, we have to change our x bounds to our u bounds. To do this, we must use our u equation, which is 3x squared plus 1, and plug in the numbers 0 and 1. And by doing this, we should get the answers of 1 and 4. These will be our new bounds. And now that we have our bounds, you must take the integral of u, which in this case would turn out to be 2/3 u to the 3/2. And we times that by 2/3, and that's from our du derivative. And once we have this, we must do the first fundamental theorem of calculus to solve for the integral of 1 to 4. And by using the first fundamental theorem of calculus, we have written out our new equation. And since our bounds are from 1 to 4, we can plug in 4 for FB and 1 for FA. And as you notice, we don't have a plus c this time because we do have a definitive integral, so there's no need for plus c. And once you get to this point, it is going to be easier to simplify in order to reduce it to the final answer. So by reducing this, we get 2/3 times 16/3 minus 2/3. And at this point, you have to simplify to make it easier to solve. So by simplifying, we get 2/3 times 16/3 minus 2/3. And simplifying even further, we get 2/3 times 14/3. And then our final answer turns out to be the same as the first method, which is 28/9. Proving that either way works, just one has they both have slightly different paths.